Have you ever considered how your smartphone recognizes your face? Or how Google suggests search results even before you finish typing? What magic lies behind these innovations? Every day, we interact with artificial intelligence, often without realizing it. It's in the predictive text that finishes our sentences, the virtual assistant that wakes us up in the morning, and the social media algorithms that curate our feeds. It's even in our pockets, enabling our smartphones to recognize our faces. This technology that seems to mimic human intelligence is all around us. But what exactly is it? How does it work? And why should we care? Artificial intelligence, or AI, is a field of computer science devoted to creating systems capable of performing tasks that usually require human intelligence. These tasks range from recognizing speech and images, to making decisions and even learning from past experiences. But the magic of AI doesn't just happen. It's not a wizard hiding behind a curtain, pulling levers and pushing buttons. It's a culmination of years of research, countless lines of code, and an intricate understanding of how our own brains work. And at the heart of this magical technology is a complex system known as a neural network. These networks, inspired by our own biological brains, are the backbone of modern AI. They enable machines to see, hear, and understand the world around them, often in ways that surpass our own human capabilities. But just as our brains are not simply bundles of neurons firing at random, these neural networks are not just lines of code. They are carefully designed and trained to recognize patterns, make predictions, and improve with experience. So the next time you unlock your phone with your face, or marvel at how your email knew what you were going to type before you did, remember the magic behind it. The secret behind this magic is a complex system called a neural network, the backbone of artificial intelligence. But what are neural networks? To answer that, we need to take a quick detour to our own human brain. Imagine yourself in a bustling city, surrounded by towering skyscrapers, vehicles whizzing by, and the humdrum of the city life. This city is akin to our brain, a complex structure of interconnected pathways and circuits teeming with activity. Our brain, a biological masterpiece, processes millions of interactions every second, learning and adapting from each one. Now let's picture a neural network. It's not a physical entity like our brain, but rather a virtual one, running on a computer. It too is like a city, bustling with data instead of people. The buildings are artificial neurons or nodes, and the streets are the connections between them. The traffic in this city is the data being processed and analyzed. Just like our brain learns from experiences, neural networks learn from data. When we touch a hot stove, our brain learns that it's dangerous and we should avoid doing it again. Similarly, when a neural network processes data, it learns patterns and correlations. For example, a neural network can learn to recognize a cat by analyzing thousands of cat pictures, identifying common features and patterns. This learning process is facilitated by something called weights and biases. These are the neural network's equivalent to our brain's synapses, the connections between neurons. The more significant a connection, the higher its weight. Biases, on the other hand, help the network make accurate predictions when it encounters new, unknown data. While the comparison between the human brain and neural networks is a useful analogy, it's essential to remember that they are fundamentally different. Our brain is a biological organ, with all its complexities and intricacies, while a neural network is an artificial construct, designed by humans to mimic some aspects of our brain's functionality. Just as our brain uses neurons to process information, neural networks use artificial neurons, or nodes, to process data. Now, let's delve deeper into the architecture of a neural network. Imagine a neural network as a complex, multi-tiered system, similar to layers of an onion. This system is composed of three essential layers: the input layer, hidden layer or layers, and the output layer. The input layer is the gateway, the entry point where all initial data enters the neural network. It's like the front door of a house, welcoming in raw, unprocessed information. The number of nodes, or artificial neurons, in this layer equals the number of features or variables in the data. Then we have the hidden layers. These are the workhorses of the neural network, where all the magic happens. Concealed within these layers, the input data is transformed, manipulated, and refined. Each hidden layer consists of numerous nodes, each with its weight and bias. These nodes are interconnected, forming an intricate web of data processing pathways. The more hidden layers a neural network has, the deeper it is, hence the term deep learning. Finally, we arrive at the output layer, the culmination of all the preceding activity. It's like the grand finale of a fireworks display, revealing the final output or prediction. The number of nodes in the output layer depends on the type of problem the neural network is solving. For instance, a neural network built for image recognition may have 10 nodes in the output layer, each representing a different image category. Think of these layers as a data relay race. The input layer receives the baton or data, passes it to the hidden layers, which refine and process it, and finally hands it off to the output layer, which crosses the finish line with the final result. In a nutshell, the architecture of a neural network is a meticulously designed system that transforms raw data into meaningful information. It's an ingenious mimicry of the human brain's structure and function, a testament to the marvels of artificial intelligence. Every layer in a neural network has its role in transforming raw data into understandable information. You might be wondering, how do these neural networks learn? As we delve deeper into the world of artificial intelligence, this question becomes increasingly relevant. Picture a neural network as a team of players in a football match. Each player has a specific role, and how well they perform their roles determines the team's success. Similarly, each neuron in a neural network has a role to play. This role is defined by two key parameters: weights and biases. Now, what are these weights and biases? Think of the weight as the strength of the connection between neurons. A higher weight means a stronger connection, and thus a greater influence on the output. On the other hand, the bias is like a tipping point, determining when a neuron gets activated. But here's where it gets interesting. Just like a footballer improves his skills through practice, a neural network improves through a process called learning. During this process, the network adjusts its weights and biases based on the errors it makes. This is the crux of machine learning. Now, let's introduce a crucial concept called backpropagation. Imagine a footballer makes a mistake during a game. The coach, in response, provides feedback, helping him correct his mistake. Similarly, backpropagation is a method that helps a neural network learn from its mistakes. It's like a coach for the network. When the network makes a prediction and it's off the mark, backpropagation steps in. It calculates how far off the prediction was and nudges the weights and biases in the right direction to reduce the error. This process repeats over and over, with the network gradually getting better at making accurate predictions. It's a process of trial and error, much like learning a new skill. And that's the beauty of neural networks. They don't just blindly follow instructions. They learn, they adapt, and they improve. Through a process of trial and error, neural networks learn to make better and more accurate predictions. And that's how a neural network, a cornerstone of artificial intelligence, learns. But how does this learning translate into real-world applications? Imagine this. You upload a photo to your favorite social media platform. Almost instantly, the platform identifies your friends in the picture. Isn't that fascinating? This is image recognition at work, an application of neural networks. They're trained to understand and identify different objects within an image, even distinguishing your friend Sarah from your friend John. Another everyday application that we interact with is speech recognition. Picture this: you're cooking dinner and your hands are full. You shout out to your smart home device to play your favorite music. It understands your command and starts playing your jam. This is no magic, but speech recognition, a marvel of neural networks. They are trained to understand spoken language, interpreting various accents, tones, and dialects to perform the desired action. Now, let's talk about something a little more behind the scenes: predictive analytics. Ever wondered how your online shopping platform seems to know what you need before you do? Or how your email filters out spam and phishing attempts so accurately? These are all thanks to neural networks. They analyze vast amounts of data, learn patterns, and make predictions about future behavior or outcomes. In the world of healthcare, neural networks are making waves too. They're being used to predict diseases and health risks based on patterns in patient data. They can even analyze medical images, like MRI scans, to spot early signs of diseases that the human eye might miss. In the financial sector, neural networks are used for credit scoring and fraud detection. They analyze transaction patterns to predict if a transaction is legitimate or potentially fraudulent. From your morning newsfeed to your evening movie recommendations, neural networks are working tirelessly behind the scenes, learning from every interaction to make our lives more seamless, efficient, and personalized. From recognizing your face to predicting your next online purchase, neural networks are the driving force behind these innovations. So what does the future hold for neural networks and AI? With advancements in technology and increasing computational power, the potential applications of neural networks are expanding beyond our wildest dreams. Let's take a moment to imagine the not-so-distant future. In the field of healthcare, neural networks are predicted to revolutionize the way we diagnose and treat diseases. From scanning medical images to detect early signs of cancer, to predicting the likelihood of a heart attack based on a patient's medical history, neural networks could potentially save countless lives. In the realm of climate modeling, neural networks could help us predict and mitigate the effects of climate change. By processing vast amounts of data, these networks could provide insights into weather patterns, allowing us to adapt and prepare for extreme weather events. In the world of business, neural networks could streamline operations and improve efficiency. Imagine a world where businesses can predict market trends, optimize supply chains, and provide personalized customer experiences, all thanks to the power of neural networks. But with great power comes great responsibility. As we integrate artificial intelligence into our everyday lives, we must also consider the ethical implications. Who is responsible when an AI makes a mistake? How do we ensure that AI is used for the greater good and not for malicious purposes? And how do we protect against AI bias, ensuring that these technologies are fair and equitable for all? These are questions that we must grapple with as we continue to push the boundaries of what's possible with neural networks. But one thing is clear: the future of AI is bright and full of potential. As we continue to harness the power of neural networks, the possibilities seem endless, shaping a future where AI will become an even more integral part of our lives. Before we conclude, let's quickly recap what we've learned today. We kicked off our journey with the intriguing mystery of artificial intelligence. Remember that neural networks, the backbone of AI, are inspired by none other than our very own human brain. We then dove into the architecture of these networks, understanding how layers of neurons work in tandem to process information and make decisions. Our exploration then led us to how these networks learn, akin to a child learning to recognize shapes and colors. We saw them in action, powering everything from your favorite music streaming service to self-driving cars. Finally, we gazed into the future, considering the endless possibilities of neural networks and their potential to revolutionize our world. So next time you unlock your phone with your face or get a movie recommendation online, remember the amazing neural networks working behind the scenes.